So as you can be able to see, we last time we talked about the cloud concepts, architecture, and design, and we
Yeah,
looked at several. We looked at what our learning objectives would be, and we actually actualized them.
yeah,
We looked at what cloud computing is, what you know, what are the common, parameters and concepts we're going to deal with here. We also looked at the characteristics. Of course, these are here, the characteristics of the cloud computing. We looked at uh, into them deeply. That in the first class. And then
yeah,
as we continued, we went to the second, that's the second class. We looked at these security concepts in cloud environment, and of course how to actually, implement them. These are how to implement them, and these are the security concepts, the three of them, the CIA triad. We went
yeah,
ahead to look at the risks in cloud environments. Here, data breaches, vendor lock-in, shadow IT, denial of services, insider threats, misconfiguration, and also lack of visibility and account hijacking. Now, we also went ahead to talk about these four uh, deployment models: public cloud, public cloud, private, um, hybrid, and community cloud models. And we went ahead to talk about their several, you know, examples of what they mean, and of course their benefits, and of course their, disadvantages or risks at the same time. So we ended that here by talking about the governance and requirements development. How do you come up with a governance and requirements, you know, say parameter as a company? How do you
mm,
bring it into play in your company? So we brought it in and we looked at what it actually means, and we looked at all these four, um, you know, um, for frameworks which help companies develop. Now, today we will be looking at something different because, as you can be able to see here, we were looking at we said that we will be talking about the the characteristics. We'll also be talking about the deployment models. So we'll also be talking about the service model. So in this module, we are going to cover the rest now, the next ones, and um, that is service model. So today, that's what you're going to cover. So today we are going to talk about the cloud service models, and in this class, our learning objectives will be to make sure that we are able to describe the three cloud service models, and two more evolving models that are coming up. But for now, we have to identify them and be able to understand in which uh, business models they thrive or they are required. And they're also going to look at the benefits and trade-offs, that is the disadvantages of each of them. And therefore, in this case, we have the three of them. We have the SaaS, PaaS, and IaaS. Now, here we always have, typically in so many companies, traditionally, we have the three of them, and each of the three SaaS, PaaS, and IaaS, they offer different levels of control what you're able to control and what you're able to do what you want, and of course the flexibility, and of course responsibility, that who does this and who is not supposed to do this. That is for the user and the cloud provider, who does what, and etc. So if you can be able to see here, uh, we have this diagram here, and as you can be able to look at that, you can be able to see the first one is the software as a service. Software, basically, it's a software that has been created by a service provider to be used by, the customer, who is you or a company, to be able to support themselves. For example, you talk about Gmail Workspace, Google Workspace, talk about Slack, talk about Jira, talk about Trello, Salesforce. All those ones, you just need to buy the space there, pay for it, and be able to use. And that is just a software that has been created and is being used by anyone. You can use it, I use it. You know, everything has been centralized, or the resources have been pooled under that server that is serving, or maybe the servers that are serving customers who handle Gmail, emails, customers who handle Google videos, even Google Meets, have their server that is dedicated to them. So you may find that right now, as we are using these, we also do not have maybe anyone using it, or maybe you may find that we are like 10 million, customers using this server to handle these conferences. So that is just a software just created, it is there, it's going to be used, and it is being used by either companies or even normal, just users, like me and you. But we can also be able to have Google Workspace that will maybe be able to register a company, and we are going to be granted all these services. We are going to be granted Meet, Gmail, and everything. And of course, we're also going to be granted the Drive, Google Drive. You're not going to have a maximum, maybe depending on how much the company that you work with has paid for the services and everything. You're also going maybe to have the online signatures and everything, or the e-signatures, sorry. We also have now platform as a service, and mostly, and of course, this one, sorry, I forgot to mention that it's normally used for by end users. This is used, that is basically an end user is someone who is definitely using the end node or the end computer for any purpose. Now, for these software developers, it's people like me and you who are using, these applications to develop other softwares or come up with other systems. Okay, so that is the platform as a service. You have been given a platform to do whatever you want. Okay, you can create another software, you can create anything. And I like the way this pyramid is. It has the smallest, the middle one, and the largest, of course. And you can be able to see how they are so well arranged. And in this case, as you can be able to see, the PaaS software developers are given an opportunity now to take, advantage of the IDEs that have been put in place for them to be able to come up with different, softwares, test them there, come up with some kind of prototypes, and be able to, actually test them live. And of course, sometimes they can use sandboxes and etc. But in this case, you can be able to see that most of them, in this case, are not most of them, actually all of them are in that other side of software development, and of course coming up with something, use that environment to come up with your own thing. Of course, that is you have been given a platform to come up with something. And as you can be able to see, AWS Lambda helps developers, Google App Engine, and also Azure App Service. They help developers to come up with applications, test them there, and of course launch them. Now we go to IaaS, that is IT administrators, mostly the IT administrators are the ones who are using it, that is the infrastructure as a service. And in this case, you are given a virtual machine. It's like where I'm seated today, I'm having a physical computer. But in this case, assuming now I'm seated here and I'm able to access a server that actually I don't even manage, I don't have the physical security for it, but I'm able to, install all the applications that I want there, that I have created, and I'm able to manage everything from that server that is physically managed by another company. So I have been given an infrastructure. So the infrastructure has been issued to me as a service. Okay, so the physical infrastructure has been given to me. So if you're able to know that we have the Azure virtual machines, the GCP machine, I mean compute, and also the AWS EC2. All these are offered to customers, especially as big developers and of course big companies, as the infrastructure. It's like accessing a vehicle that you actually you're not the one driving it, okay? You're not the one, who ensures that it is filled with fuel and everything. So you are given a server that you actually access virtually. Okay, you don't have to be going there, connecting to your laptop the virtual, I mean the Ethernet cables or even the patch codes, and trying to ping to find some other end node or even a server. No, you just do it from your desk, from your machine, able to access all these servers and do it virtually without connecting any cable. So basically, that is the infrastructure that has been issued to you as a service. Now, in this part, we are going to go a little bit faster. So, although I've already talked about it, but I think this is just going to be an icing. So, software as a service, it's a cloud service model where software applications are delivered over the internet instead of installing running applications on your own computer or server. You access them through the web. That is maybe let me say browser, because you're connected to the internet. And if you're able to remember, we looked at the characteristics. Okay, you can only be able to access them when you're connected to the internet. Now, the cloud service provider hosts, manages, updates, secures the software. Gmail, for example, that is nothing that you do. You have never been told you have never been told that, oh, so Chris, maybe we need to update your Gmail. No, you just wake up, maybe something has changed, and you just continue using it, email sent, etc. Anything, any tab that has been added, it's not you. There is no way you have been told to do it. No. So basically, it is the cloud service provider who does everything. So you as a user just need to log in and use the application. Okay. So there is no setup kind of, you don't need to have, the only thing you need to have maybe as an infrastructure is your own machine or your own, let me say your own computer, because a mobile phone is a computer. So basically in this case you only need that. Then let's talk about some of these examples. So some of the software as a product applications are Gmail, Yahoo, Mailchimp, Apple, all those ones. Okay, and in that case we'll be able to actually look at it and go deeply. So that's great. Now, as you can be able to see here now, we already talked about the three, this pyramid, the SaaS, PaaS, and IaaS. We have looked at these examples and we have talked about everything. We have now defined what a SaaS is and what it basically means, given examples. Now we are going to talk about the examples. Now, Gmail, Yahoo Mail, Mailchimp, Apple Mail, yeah. All those ones are examples. Then we have also Google Drive, Google Docs. You are given an app to store everything. You're given an app to handle your documents. That is, that's still the same. Dropbox, Zoom, Zoho. We have Salesforce, Zoho CRM. We also have Canva. We have Adobe Creative. All those ones are offered as SaaS applications. And this explanation here will be able to also help you because Gmail, Mail, Yahoo Mail, MailChimp, they are cloud-based email which you access through a browser without installing anything. You don't do anything. I mean, with this. However, they have an application that you can install to make your work easier. But then sometimes you really don't need to install them. If you don't need that app, you still can be able to access them. So there is nowhere that is written some must you have them. You also have the online document handling, document handling and storage services, Google Drive and Docs, and of course also Dropbox is there, though you cannot be able to edit, but you can be able to store and share. We also have Microsoft 365, which has Outlook and Word Online. You can process everything online, including the email. You can email blah 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 at outlook.com, etc. And of course, you also have the spreadsheet apps there. If you've ever used 365, you're able to see to know all this because it also has these Google Docs there. Zoom, online video conferencing. We have Salesforce, that is the CRM system that is used to help track the customers' engagement. We also have the Canva, Adobe Creative, which help in designing graphics. We have also here the what you're supposed to manage. You as a user, you just need to either have the software or be able to access it on the browser. What the provider manages is everything like the application, the runtime, the operating system, infrastructure, everything. Like everything. The only thing that you're supposed to manage as a user here is in the part of security to make sure your password is strong. We also have where they are commonly used. Um, of course, we have the email and communication tools. We also have CRMs. We also have collaboration tools like the one we are currently using today, which is Google Meet. We also have enterprise resource planning that in most cases are used to connect so all the systems in an organization. We also have some of the advantages. What are these advantages? You're able to access them easily. Of course, Gmail, you can easily access it. You don't need to install it. However, you can install the applications where they are, Android based, Mac OS based, etc. You can also have some of the low upfront costs. For example, if you want to pay for a little, space in, for example, the not the Gmail, but in the Google Drive, automatic updates. You don't need to be doing anything. You don't update your Gmail or your Google account. It always updates. Scalability you can easily increase. Uh, as them as the providers, they can be able to increase the number of users they want to have or reduce them. So collaboration friendly, that is basically means you're able to have multiple users, okay, who can be able to work on the same file in real time. For example, Google Docs, if you have the Google Docs, say the spreadsheet, you can be able to fill the details. You can say, okay, in this column, I'll be filling this column with data. For example, if you are data entry clerks, you're able to fill them and you're able to see actually in real time that somebody else on the other side, they are filling some details and what they have actually filled. also security and backup. The provider manages the backup and security, and that's the very big advantage, because you as a user, you don't need to struggle to know what is there and what is being used. What are the disadvantages? You have to connect the internet, of course, especially in this part where we are. It is definitely expensive. You don't have any control of the software. That is, you cannot customize. You only use what is there. As I already told you, for example, the theme. If the theme is there, we have the black, blue, and I don't know what, which color, maybe hot. That's what you're going to use. If there are only three themes, you can't come up with your own. That is the fourth thing. That is security risks. Of course, there are so many risks. If, for example, your password is compromised, your data is going to be at risk, because everything you have stored in the, say, Google Drive is going to be accessed by the unauthorized. Okay. There is also limited offline access. However, currently we have some companies who are offering offline services, especially when you're not connected to the internet, you're able to access and change some stuff online. But most of them do not offer this service, so it's so limited, really, really limited, and it always requires that you access, you are connected to the internet. And the login, I think we talked about this, where you're going to have issues, especially when you're trying to migrate from one service provider to the other, and when this data is going maybe to be so expensive, and sometimes these two service providers have some kind of two different principles that uh, go against each other, and therefore when you try to move this data from this provider to the other, it becomes so hard, and therefore that is the vendor lock-in, and it makes you as a user, your work as a user, very difficult. We also have a software as a service in cloud cybersecurity, and we are going to talk about the what the cloud, what SaaS provider, that software as a service providers must ensure. First of all, is they must ensure that there is strong access control. That is, for example, multi-factor authentication, which has successfully, for example, been implemented by, say, Google. In, for example, when you're trying to access your account from this device, and then you have not logged out, again going to access using another device, it's definitely going to prompt and ask you, is it you? So that's part of multi-factor authentication. There's also the code that is being sent to the user, either in another recovery email or your own email. You also have data encryption. They have to always encrypt the data on transit and at rest. Regular vulnerability scans are always done, and of course, security updates are done. Backup and recovery procedures are always done, and of course, the compliance with the data protection laws, for example, like the GDPR, are also done. So basically, in this case, this is what the SaaS providers like AWS, Google are supposed to do. Yes, they should comply to this. Now, you as a cybersecurity professional, you must evaluate and monitor the SaaS apps, that is the software as a service provider apps, um, and what they're being used in your organization, and what they're being used for, and how they perform. So make sure that as a professional, you don't introduce data leak, where data can be able to be transmitted from a user to another user. So make sure that this data, even if it is leaked, it is always encrypted. That is, if they do not have that key, that is encryption. If they do not have that key, of course, they're not going to, even if the data is, uh, leaked, there is nothing they can do with it. Make sure you always configure. Nobody is able to access documents that are not meant for them. And lastly, you can basically it's the same, you're only able to access what you're supposed to access. If I'm supposed to access 1, 2, 3, 4, I should not be able to access 5. That is it. Then we have platform as a service. That is where we have now developers. Okay, you know, the platform, the PaaS is a cloud computing service model that provides a ready-to-use environment for developing, testing, deploying, and managing the applications. That is, you are there, you want to develop. Okay, it's like GitHub. You said GitHub, you also have Git. All these ones are actually PaaS. Now, maybe I should I should not give you the analogy, but it's self-explanatory. It's like renting a house. I mean, house that has always is finished. Then now that platform as a service is like renting a workshop where you have all the tools, the materials to build your own product, but you do not need to worry about fixing the electricity. Okay, it's like someone has said, okay, fine, I will have a workshop. It has everything. Um, what you need to go there with is only your tools and your energy, and the materials start working. Electricity will be paid by the owner of that workshop. Okay, everything will be paid for. So just go with the energy there. So basically, that is the platform as a service. So and it's always cloud based, of course, for developers, and it gives you everything you need to do to develop something. If you want to work with Java, you want to work with Node.js, you want to work with, say, for example, Python, you have everything C++, C sharp, everything is there. So what you need just to do is just pay for that space and you do whatever you want. Sorry. So some of these examples are the Google App Engine, Microsoft Azure services, Heroku. All these ones actually used to in development of applications. Okay, all these ones. So make sure you also go through them. I'll be able to share all these notes. I remember I have not been able to share the. I think I've shared. Then we also have the. All these ones are examples of past products. Then we also have the what you manage as a user. You only manage your applications that you have developed and the data that is being processed by the applications. Simple. Security, runtime, middleware, the OS, the servers, storage, networking, nothing. This is none of your business. This is being, managed by the service provider. Then we also have some of these common uses of the PaaS as a service. As when maybe you want to develop mobile apps or even web apps, application hosting, as you want to host an application. Um, for example, API development and integration. That is, you want to develop or even integrate an API with some other APIs. Of course, you have to be managing all these APIs as a company, or maybe two companies working together. DevOps, that is development operations pipeline, where you have some automated processes that are supposed to help you to streamline the software development lifecycle. You have to use the um, platform as a service, where, for example, you have so many developers. Let me just use that example. You have so many developers working on a single software and they're developing it. So basically, what you need to do is to make sure that you have a single platform where they're able to interact. That is the pipeline. Okay. Then we also have the advantages. So what are some of these advantages of the uh, platform and service? Speed up development. Basically, you as a developer, you're able to focus on coding. You don't need to care about setting up the servers. Trying to kind of do some customization on those servers. You don't have that time. So it basically speeds up the development of the applications. You do not have to manage, the infrastructure, you know, because the provider is able to handle all this. Okay, and also, of course, building tools and frameworks. You have the tools that you want to use there. You have NetBeans there. You have the you also have, say, for example, these for example, the Jupyter notebooks there. You have everything there. You can actually choose what you want to use. Okay, it's like saying maybe I want to sit on a red chair, sit black, anything. You can choose whatever you want. So everything is there. So you just need to select what you want to use. Scalable by design basically means you can easily grow the user. That is, you as a provider. You don't need to say, okay, fine, I have 10 users, I can't add more. You're able to add more. Collaboration, that basically means 10, 2, 5, 3 can be able to work on one given application and develop it. And it's also cost effective for development. So you are not going to buy all those servers, come and configure them, etc. So it is very cost effective. What are the disadvantages? Of course, you do not have any control over the infrastructure. Just develop and go. I mean, you are not going to say, okay, fine, the operating system is so slow. I want to update it. For example, maybe the service provider wants to update the next 10 days. But in your case, you just want to update today. Of course, it's going to give you issues. You're not going to to update, definitely. So it's going to give you issues. Then the login, we already talked about that. Security dependency. I mean, you only rely on the security that has been provided by the provider. The only thing you do for your case, just provide your strong password, and that is it. Anything else, nothing. Limited customization. You cannot customize. I think we already talked about this. You cannot customize as a user. You know, the platform as a service. You only use the options that have been given there. If we have option 1 to 10, there is no 11, so you cannot bring it. Resource constraints. Sometimes you may have moments where you as tenants are so many of you at that time, and therefore sometimes it can also slow down the performance or even of that even say server, and everything can go slow. We also have uh, what in especially in cloud security, what the PaaS platforms must ensure. So for as a as a platform, as a service provider, you must ensure that there is secure coding practices. There is input validation and encryption. So you're not going just to give people spaces to just write their own things, and when maybe someone access the accounts, nothing is there, everything has been wiped out. Maybe the person has already known what code they were writing. So you as a provider, you have to ensure all this. Input validation. Anyone who is going to key in. It's like, for example, Google. Let me say Google. Okay, of course, it is just you know software as a service, but it's like Google, say Forms. They give you a space as a developer when you are developing that form, trying to send to people to respond. Let me say responders to respond. You have to validate whether that question must be answered or maybe it's just optional. Yeah, basically that is the example that these PaaS providers should ensure that when, as a developer, I am developing something, encryption has to be automated, validation has to be automated, authentication and authorization mechanisms, who role-based access. That is, if your role is an admin, if the role, for example, I'm just a normal user, I should be able to access all those services. For example, if it is read-only and if it is read with edits, I should be able to access if I am allowed to access. Network security. You are the one to work with, for example, virtual private computers, firewalls, everything, the security. Application layer protection. You have to ensure that you protect the application layer. You also have to comply and support all the compliance to that given platform. Then we have infrastructure as a service, where we have which is it's actually a computing model which provides virtualized computing resources. For example, you're given a server, but you don't have to touch it. Maybe sometimes you have just been told, maybe we have given you a space to store your data. I mean, just stop. So it's like being given a hard disk that you can't touch. Okay, or even networking. You just connect all your devices or maybe your people virtually. You don't need to have all these, you know, visually. Say, for example, um, uh, the light beams, for example, that is, if you're using radio frequencies, for example, if you're using the switches, etc., the routers, you don't need to have them physically. You're able to access them uh, virtually. So you actually rent, like given it's actually like renting a house that you have not entered inside. Okay, you haven't entered inside, but you can be able to enter virtually. Okay, so basically that is what it means. So now, what are the examples? We have Amazon Web Services. Can be able to give you as a company everything you want to access and use. Microsoft Azure. We also have Google Cloud Platform, and of course these four are five, sorry, are very common. We also have IBM Cloud Infrastructure and also Digital Ocean. All these ones, but for Digital Ocean, they are more inclined into developers. Okay, it's more developer friendly. All those who are developing softwares, so much into developing softwares. But when you go, for example, to AWS, or let me just say Google Cloud Platform, they're going to give you yes that development space, but you can also request other services like Gmail, etc. Now, what do you manage as you only manage the applications, the data, the runtime, because that is the infrastructure. So you have to be the one who knows what you're going to schedule for what time. We also have the middleware, and we also have the OS. If, for example, you want to use Linux, that's your problem. If you want to use Windows, that's your problem. Unix, that's your problem. So basically, you manage whatever you want to use there. So it's basically you've been given something that is physical. You can access it and use it, but then you can't access it physically. So you can be able to manage all these ones. Remember, all these features can be able to be accessed physically. So imagine something that you can now not be able to, you cannot now be able to access physically, but you can access it virtually. So still, it's still the same. The only thing is that you cannot be able to touch it. Then we have what the provider gives you, what they manage, but the virtual machines, what they actually manipulate and be able to help you with the machines, the storage, the networking, how they're interconnected, the physical infrastructure, they have the CCTVs, etc. Data centers, everything is there for them. They understand and they know that you are not able to go there physically, so they do that for you. Um, and given that the infrastructure, the service is a shared responsibility, the provider secures the physical infrastructure. You do not need to go there with your security guards to guard it. Okay. And for you as a user, the only thing you need to do is make sure you guard your OS, the applications, and also, of course, the data. And the others will be done by them. Yes, and then we also have the common users, of course, web hosting. If, for example, you want to host your web app, or maybe the website itself, where you, for example, you want to test your application that you have developed, you're going to be given that space to test it. Okay, Maybe you can be able to say, okay, fine, maybe I want to test, spin up the servers, look at which server I can be able to use to run my application, or maybe it can be able to be accessed by users from, say, continent Y. I'm not interested, say, from by users from continent X, etc. We also have disaster recovery and backup. Of course, if, for example, you are running your own data center and you feel like, oh, sometimes anything can happen here. Maybe we are prone to fire, we are prone to floods. I just need to back up my everything on these other, infrastructure as a service provider, so that if everything is burnt over my end, any other thing can be done. We also have big data analytics, for example, where you have millions or trillions of customers or records to be, analyzed. You can be given that space virtually to be able to access that space and be able to do analytics. You also have the game hosting. I believe you understand how game hosting. Uh, for example, a game is somewhere. I think you have seen people playing a game from their devices. Say, for example, you're seated somewhere and you're playing a game with someone else, maybe not physically present with you. Maybe they are um, 500 kilometers from you, and though you're playing the same game, so the same thing, so you're able to um, have several players accessing the same game at the same time. Of course, virtual machines. Towards the end, we'll be able to talk about these virtual machines. Okay, you can be able to create everything. It's a machine you have been given. You can't touch it, but you can configure it. It's like your laptop. You can just configure your laptop to do anything you want. So basically, the same. It's the same thing. We also have some of the advantages of infrastructure as a service. Pay as you go. I mean, it's simple. Just pay for what you want and then you move. Highly scalable. There you're able to, as a provider, you can be able to add people you want, or maybe you as a user, you can be able to add the space that you want as you continue. Full control. These are an infrastructure, so you have your operating system there, you have your own configurations, so you do not have any problem. If you want to have your own operating system, fine, that's okay. Quick setup. You can deploy this, deploy the servers and apps in minutes, not weeks. You don't need to have someone importing them to you, and you have to maybe waiting for them at the port, bring them in, carry them, using, say, transit and etc. No, just go sit somewhere on a desk and you do everything. You do your setup. You do not have to worry about the physical hardware, where maybe there is a lot of space that you actually need, to buy them, to maintain, have experts maintaining them, the heat. You understand this, even the electricity they are going to use, you do not have that time. And the good one good example is that you can actually experiment your operations using the infrastructure as a service without actually buying anything um, from outside. What are the disadvantages? Um, the user is responsible for the security, all the configurations, everything. That is you. Basically, what they do, they just give you everything. It's like going to a house and you're being told this house is new and it's open, the doors are open. So what do you need to do? Just need to buy, um, say, padlocks and start managing them, install your CCTVs, etc. So basically, that is the example. You also have, you need to have, as a company, technical skills. If you do not have engineers to be able to configure all these, this infrastructure, be able to secure it, be able to do everything, and have all these applications there. So, for example, the software as a service, you don't need to have all these, technical skills. You have people who have never done IT, they're able to handle Gmail. But for example, infrastructure as a service, you have someone who knows how to configure servers. Sometimes it can be very expensive if you do not monitor the usage, and also it's so there is some kind of complexity because you need the IT knowledge. If you only have people who are great in IT, you're going to have problems. There are no built-in apps. For example, in software as a service, you have some applications that you know, uh, have already been installed and you don't need to be configuring. But in this case, you have to install everything new as it is and you configure it everything as it is. Okay. Then we also have internet as that is IaaS in cloud cybersecurity context, and we can talk about some of the responsibility um, of the user. See, for example, that is you as a user. If you're a company, you have to focus on access control, data encryption, network security, patching. That's updating. For example, the security patches, even the operating system patches. Also monitoring. It's you to monitor everything. If someone is trying to access, you do not have to depend on someone else. For example, if for example Gmail, someone is trying to log into your account, do you know they are going to send an application, I mean a message or even an email to your phone that someone is trying to log in. But for infrastructure as a service, that's your work. Make sure you monitor and you do everything. Okay? It is you to update yourself. We have two more evolving cloud models. We have function as a service, which is a cloud computing model that allows you to run small pieces of code, which are functions, in response to events without managing servers. You do not have um, to worry about the servers or anything, just manage some functions. And we're going to talk about those examples. Basically, what you do is you write the code, you upload it to the function as a service, that's a fast platform. It executes automatically when triggered by an event. And in this case, I think I'm going to give you a very good example here where, for example, it's like, for example, someone has been uploading notes. In normal cases, I think the goodness will be uploading. Yeah, for example, someone is uploading something and it reaches to another level that as a company you do not allow. For example, you do not allow files that are over, say, 3 MBs. So someone tries to upload a file that is over 3 MBs. So basically, that function as a service, that code that you wrote there, basically means into our server. The only thing a file, for example, even if you're applying for a job, if that file exceeds this, you're going to send you a message that this one exceeds this, and therefore you rather upload a maximum, uh, you know, size of this. Okay, basically that is a function as a service. So we have some examples. For example, in image or file processing, sometimes we also have those systems that if um, say in a HR system where you have been told you have to have this profile. No, let me just it is it's called what, passport photo size of these and these dimensions. So in most cases nowadays they do not have that. So basically what you do, you upload your size, whatever size photo, then the system automatically just redesigns it to whichever size that is needed. So that's actually a function of the service. We have scheduled tasks, say for example the cron jobs, where um, you say, for example, a machine say updates every time at say 2 a.m. Say your WhatsApp backups your data at exactly maybe 12 a.m. Okay, so basically that is scheduled tasks. We also have real-time data processing. For example, when some data is added to some space in a database, um, you're able to have the streaming logs. Maybe there is that also queue that is there that is being able to be monitored. You also have the chatbots, able to speak to an agent online that is actually not a human agent. We also have security automation. You can automate triggers where, for example, someone access a system and they just send a signal. We also have the internet, the IoT, Internet of Things, device management, where you can be able to have a sensor uh, that picks details other than having a server that runs 24/7. So you have just a device. When something comes across, just picks it, then it goes. When it comes, it picks, goes. Okay, not when you have a server that is just seated there waiting for things to come. You go 1 week, nothing has come. You have spent energy and everything. Then we also have containers as a service. Which allows the users to manage, run, and scale applications using containers without worrying about the underlying infrastructure. And sometimes you might think about it about being like software as a service. But in this case, the containers, it's, think about containers. Now, when you have the containers, you having something like buckets. Buckets are carrying something, small, pushing it from one place to another. But when you talk about the software as a service, for example, you let me say, for example, the platform as a service, there's so much inside there running. You have, for example, if you want JavaScript is there, Java is there, C++, C Sharp, everything. But in this case, it's just these are lightweight, they are portable, they're very portable. So in this case, you only having containers as lightweight portable units that package an application with everything it needs to run. That is, you have the code there, the libraries, and also the dependencies of that given code. Let me say the dependencies of that given application. So it is just one thing. So it's being handled as one, not as you are able to choose so many options. Okay, so these are just upcoming, and we are not talking of them as things that have already been, put forward, currently being used, but they are currently there. However, uh, the cars are typically built on top of the container orchestration platforms like the Kubernetes. We also have the Docker, the Docker Home, sorry, and also maybe the OpenShift. That's where they're building. Like from there, you don't need to be picking, selecting options. You just go and pick. This is what I'm going to use, and you put the other ones aside, and then it becomes the container service. It's like going, for example, to um, a shipping company and saying, "This is the container I want to carry my luggage." You don't need to go and say, okay, you don't need to go and tell them that, oh, you have 10,000 containers. Just pick any one of them and put it here and then let it carry it. No, just go there and say, this is the one I want. And then you let it perform whatever it wants. Okay. Examples, we have microservices deployment. Um, um, that basically will you'll have it, or maybe translate to something like you want to, let me say, the microservices only performing only a task that is so much required by the company, and you don't care about the others. We also have, the development and testing environment. You can be able to be given that space to develop an application that you have developed, say, for example, in Java or even Python, and you just test it there. So that's an example. Then we have uh, maybe some of the risks that we can actually talk about in this case. What are some of the risks that virtualization, make to us? Virtualization basically means you're not able to control anything. You just meet it virtually. You don't even touch it. So what is virtualization? is a technology that allows the user, or even as physical machine, or anyone, or let me say a machine, to be divided into multiple virtual machines. We'll talk about virtual machines later, each acting as or like an independent computer with its own operating system, CPU, memory, and storage. So you have a computer, let me say a server, that you, if you're operating it physically, you just say generally this is it. You don't, it's like, okay, let me just take you back to partitioning a computer, a hard disk or an SSD, a solid state disk. You have it as a solid state, but you can decide and partition it and say someone else will be using this partition A, someone else partition B, someone else partition C, and someone else partition D. Simple. So, and make sure that partition A cannot be able to access partition B. And neither of the three, C, D, B, A, can be able to access any. So basically that is virtualization. Okay, so what are the risks? Okay, now let's talk about it. We have hypervisors, where a hypervisor, which we call, you will also understand this because we'll talk about it so many times. Uh, that is a virtual machine monitor, is a software that's the software layer that allows multiple virtual machines to run on one physical host. Okay, so you have so many virtual machines. It's like having those spaces, those partitions. They are only having one. Let me just use one which is common, which is the hard disk. It's very common. The only one hard disk, and you have 10 partitions. Now you can say, you can call those hypervisors. Okay. Now we have several types. First of all, we have the type 1 hypervisor, which is we call the bare metal, which runs directly on the physical hardware. It doesn't have the underlying OS. And this one, that's why they call it the bare metal. So there is no operating system. It's like it is embedded directly to that given say hard disk. So there's nothing that is virtual. It's not a virtual software. It's not a virtual operating system. Okay. So we call it the type 1 hypervisor, which is the bare metal, which manages the guest virtual machines directly. So if it is a guest virtual machine that is coming in, maybe that is being created, it is the one that manages it. It's more, of course, it's more secure because you do not have to have another layer, which is an operating system. Imagine you have the hardware and you do not have the operating system. Basically, it means you are more protected. If you have the operating system and you have the virtual machine, if an attacker wants to come in, they are going to have two options: either attack that operating system or attack the physical hardware. So it is more secure and efficient. Then we have examples. Of course, these are examples you're going to meet. You don't need to have them so much kid in your head. It's good that I had them here, but though your syllabus doesn't say that you must look at them, though it's good, as a cybersecurity professional to know them. Risk profiles, low attack surface. Nice one. I think I already talked about that. Low attack surface. You don't have the operating system, you don't have the hardware. So you only have the hardware. So if someone doesn't know how to access the hardware and how to do anything on them, that is it. So the surface is small. But if they do not know this, and later they know this, that surface becomes big. So they're able to access and be able to attack. Then we have these target for advanced attacks due to its high privilege level. Of course, I've already mentioned that. We have type 2, which is hypervisor, which is hosted now. You have the operating system, which is being hosted on top. Okay, it's like we'll talk about them because there is another part that is, being this one we are actually highlighting. So the host is operating. I mean, the operating system has a host. It's like, for example, where you have your machine and also you have an operating system. You're able to have your everything there, and you're able to see that what is being run there. As an operating system, you handle everything, the files. Somebody is able to store everything there, and you're able to see them. Then we have all those examples. So risk profile, of course, vulnerable because you have two attack surfaces. You have the operating system, it can be attacked. You have the hardware. I think we already talked about that. Two attack vectors, where you have the guest escape. You are like you are a guest. I'm a guest. Sorry, that's virtual machine escape. Call it guest escape or virtual machine escape, where a guest escape occurs when processing runs inside a virtual machine and it breaks out and executes a code on the host machine. And of course, that can be very dangerous. And in this case, if that one happens, basically means everything is going to be broken out. I mean, everything is going to be thrown out, and they are going to sniff the data that is on the other machine. It's very, very dangerous. So I'll give you time to go through this because I will send you this file. Why it is dangerous. We also have the host escape. Remember we talked about the guest. Now this is the host. The host now is the big machine. Okay, that is where process on the host machine. That is the host process operating system, which is in type 2 hypervisors. That is of course called the type 2 hypervisor. Sorry, where maybe it has been misconfigured. Okay, and is able to access and manipulate virtual machines improperly. You have the big, it's like having the prefect, able to enter into the other pupils or students' heads and be able to pick what they have thought or what they have thought about. So, what are the risks? We're also going to go through that. We also have what we call information bleed. Basically, information bleed is data leakage where information bleeds or maybe leaks from one virtual machine to another. And basically, that means if you are a company managing company A and I'm company 2 managing company B, and if data leakage happens, it basically means I'm able to access you. Remember, I've talked about cloud computing where you as a company are able to access the same systems that I also use, okay, or we can be able to share because this is infrastructure as a service. So if we are sharing and my information, is not intact, it can be able to leak to you and you can be able to see it because we share the same server. Okay, so basically that is what it is, and of course you're also going to go through this part, which is I don't think has any problem. Yes, so that is the end of today's class.